Hi everyone, welcome to my video sessions on complex number. This is my first video on modulus of complex number, so that you people at home can actually go through the video and do the exercise in delta mathematics. Now, looking at modulus of a complex number, let's say z is given as x plus iy, and if I write modulus of z is given as square root of x squared plus y squared. In other words, modulus of z can be written as this. This is real part z whole thing squared plus imaginary z whole thing squared. So if you can just remember real z squared plus imaginary z squared, and that basically goes down to that, because the complex number is always given to you as z is equal to x plus iy. So if you have a look at this diagram over here on the right hand side, you'll notice that that distance there, let me change the pen over here, is, okay, choose that. So that distance there is y, that's a right angle, that is x. So what's going to happen is modulus of z comes out to be, this is modulus of z, so that is going to be simply x squared plus y squared. So we can say modulus of a complex number, so modulus of a complex number is the distance from the origin to the complex number z. Now, with complex numbers, remember one thing, that you are not able to actually say which complex number is bigger and which one is smaller, because the complex numbers over here that we deal with are done in 2 dimensions. So it is, it's not easy to compare complex numbers. So one thing we can do though is we can compare the distance from the origin, and but you just need to be careful as to how you do this. Alright, let's just go and have a look at an example. Let me choose my pen over here. Okay. Oh, where did this pause? Example. So calculate the modulus of the following complex number. The first one is 3 plus 5i. The other one we want to look at is minus 2 minus 6i. Sorry, let's change this to plus 6. Third one is minus 2 or minus 3 minus 5i. Okay, so if I'm going to do the modulus of these complex numbers, so the first one is modulus of 3 plus 5i is going to be simply 3 squared plus 5 squared, which is going to be 9 plus 25, and that gives me square root of 34, and you can leave your answer like that. Number 2 is modulus of minus 2 plus 6i, and that again is going to be negative 2 squared plus 6 squared. Now when you enter minus 2 on your calculator, make sure you have brackets, because otherwise the calculator will spit out a answer which is negative. And remember, when you square a negative number, it is always positive. So this is going to be simply 4 plus 36. That comes out to be square root of 40. And number 3 here is minus 3 minus 5i is going to be 9 plus 25, and this one is again 34. Okay, let's try a few more. So calculate, let's do a over here, modulus of 3, b modulus of minus 4i, and c, you say modulus of z plus z1, where z is equal to x plus iy, and z1 is equal to 3 minus 5i. Alright, so looking at the first one, a modulus of 3. Now what you notice over here is the real part is 3 and the imaginary part is 0. So this is just going to be 3 squared plus 0 squared, which is equal to just going to be 9. If you want, you can write this as 3 plus 0i b. And similar thing happens with the next one, which is minus 4i, and that is same as saying it is 0 minus 4i, and that will be 0 squared plus minus 4 squared. That is just going to be square root of 16, which is going to be 4. Now C is interesting. It says modulus of z plus z1, where z is equal to x plus iy and z1 is equal to 3 minus 5i. So what we'll do is we'll substitute those in here. So z1 is x plus iy, and then plus 3 minus 5i. So now what I'm going to do in my next step is I am going to collect all the real terms. So x plus 3 plus I into y minus 5. Now I will find the modulus of this, which is equal to x plus 3 squared plus y minus 5 squared. And so what this gives me is it's going to be, you can leave it like that, or you can go x squared plus 6x plus 9 plus y squared minus 5y plus 25, and you can simplify this as x squared plus y squared plus 6x minus 5y plus 34. That's it. Thank you.